So today we're going to continue in assignment number 2, but instead of talking about direct variations, we're going to talk about inverse variations. So let's go ahead and get started. First, I'm going to look at this example. Suppose that there's a end of the year trip being planned to Cedar Point, and a bus is $120 to rent for the day. And so you know that the number of people that are going on this trip depends on what the cost is going to be. And so let's just go through here and look at one person. If one person is going to go by himself and go on the bus, it's probably ridiculous to do that, but he's going to spend $120 on the bus. If there are 2 people, well, then they split the cost, and it's going to be $60. If there are 4 people that go, well, we would take 120 divided by 4. Well, that would end up being $30 per person. If we can get up to 10 people, well, the 120 divided by 10, that would be $12 per person. 20 people, we would take 120 divided by 20, that's $6 per person. If we can get 40 people to go, though, then 120 divided by 4 is $3 per person. That sounds a little bit more reasonable. What we're going through here is an inverse variation. An inverse variation is simply an equation that looks something like this. We're going to have 120 divided by x. And so a direct variation, we know, was something y equals k times x. Well, an inverse variation is y equals some k value divided by x. And so the graph of this is kind of interesting because there's really 2 parts of this. I'm going to just graph one part right now. I know if I'm over here at 1, I'm all the way up at 120. If I go over to 2, I'm down to 60. If I go 4, I'm at 30. 10, I'm at 12. 20, I'm at 6. 40, I'm at 3. If 120 people went, I'd be at $1 a piece. And you can see the graph looks something like this. That's called a hyperbola. If we plugged in negative values for x, we would have negative values for y too, and it would be a reflection on the other side. It would look like this. And so you can see here that as the x values get bigger, the y values get smaller, and that's kind of representative in this chart too. The more people we get, the cost actually goes down. And so what is an inverse variation? Just like what we did yesterday, an inverse variation is of the form y equals k divided by x, as opposed to y equals k times x for a direct variation. Generally, as one variable goes up, the other variable goes down. The k is still called the scalar, or the constant of variation, just like in a direct variation. An example of this would be our bus ride, y equals 20 over x. So let's take a look at some more examples. First of all, this example. Can we figure out what the equation is going to be? Well, let me start with this. If I have y equals k times, or k divided by x, and I want to solve for k, I'm going to multiply both sides by x. And so that means my k value is going to equal x times y. So if I multiply my x and my y values together, I'm going to get my k value. 3 times 12 is 36. 6 times 6 is 36. 18 times 2 is 36. And my equation here is going to be y equals 36 divided by whatever x is. 36 divided by 3 gives me 12. 36 divided by 6 is 6. And 36 divided by 18 is 2. And so the graph of this equation is going to look something like this. 1 and 36, I'd have a point at 6 and 6, and maybe 18 and 2. It's going to be a hyperbola that looks like this, and it's going to be the same thing on the other side. Probably a key point is right here in the middle. This point is related to that 36. If the x and the y are the same, that means the x times the y are the same thing. They multiply together to give me the 36. That means that x and y are both the square root of 36. And so I know that this point right here is going to be the point 6, 6. Let's go ahead and take a look at a different situation. 2 gives me 48, 4 gives me 24, 12 gives me 8, 16 gives me 6. If I multiply these together, I get 96 here, 96 here, 96 on all of these, which means my equation is going to be y equals 96 divided by x. And my equation, I'm going to have 2 of these hyperbolas. Probably the easiest way to graph this, it's not going to give me an exact number, but would be to take the square root of 96, which is about 9.8. So if I went about 9.8 over and 9.8 up, I'd be about here. And if I plugged in, if all of these values here were negative, then I would take 96 divided by all those negative numbers, and I would get all these negative numbers too, which means that I'm going to have the same graph over on this quadrant, which is the third quadrant. And there are other points that we could graph in there as well. But these points, notice that these graphs do not go through the origin. As one value goes up, the other value is going down. And so let's continue by looking at some more examples. Let's graph y equals negative 9 over x. Suppose the k value is negative 9. We could make some x and y values here. Like, for example, I can plug in 1 for x. Y is going to be negative 9. I can plug in 3 for x. Y is going to be negative 3. I can plug in positive 9 for x, and y is going to be negative 1. Well, this is a little bit different because the k value is negative, but I'm going to have the point at 1, negative 9 is going to be about here. 3, negative 3 would be here. Positive 9 and negative 1 would be over here somewhere, and so I'm going to have a hyperbola that goes in the fourth quadrant. This point here in the middle is the point 3, negative 3. Is the point 3, negative 3. And if I made all of these numbers here negative, then when I divided by a negative divided by a negative, all these numbers would be positive, which means I'd have a point at negative 3, positive 3, and it would look something like this. We have asymptotes along the x-axis and along the y-axis. All right, so let's take a look at this, the other one here, y equals 2 over 3x. Well, one thing that I think it's important for you to see is that this is the same thing as if I wrote it like this, y equals 2/3 divided by x. Because if I take 2/3 divided by x, that's the same thing as multiplying by the reciprocal of x, which is 1 over x. So if I multiply these together, I get 2 over 3x. So 2/3 divided by x is the same thing as 2 over 3x. In other words, the k value here is 2/3. And so my graph, it's going to be a little bit more complicated to do this one, but if I take the square root of 2/3, I'm going to have to use my calculator for this. The square root of 2/3 is roughly 0.8. So I'd go over 0.8 and up 0.8, and it would be a hyperbola that looks like this. Negative 0.8, down 0.8, and it'd be a hyperbola that looks something like this. And so, again, they don't go through the origin, but they do have a horizontal and a vertical asymptote that these lines are going to approach, but they're never going to touch. Let's take a look at one more example here. Let's take a look at the graph of this function, y equals 9 over x. I think we were doing this a little bit already, but we know there's going to be a point here at 3, 3. We're going to have a point here at 1, 9. I'm going to assume that that's close to 1, 9. And 9, 1, which would be roughly here. And then my graph is going to look something like this. Same thing in the negative direction. I'm going to have a graph that approaches the x values and it approaches the y values, but it never will exactly touch those. That's why we call those the asymptotes. If the 9 was negative, instead of being in the first and the fourth quadrants, I would be in the first and the third quadrants, I'd be in the second and fourth quadrants. And then eventually we're going to be shifting these around, so shifting them up to the right and so on, but not right away. Let's take a look at some examples. We did these with direct variations yesterday, so let's take a look at if we have an inverse variation at 5, 8. We want to first write an equation, and then we want to figure out what is y if x is 20. And so with this one, we know the equation is going to be in this form, y equals k over x, because it's an inverse variation. But to figure out what the k value is, I'm going to multiply my x and y together. My x and y, if I multiply them together, gives me 40, which means my equation is going to be y equals 40 divided by x. And so here's my equation. Then if x is 20, I'm going to have y equals 40 divided by 20, which means my y value is going to be 2. Let's take a look at a different situation. And again, I would, just like yesterday, I'd like you to pause the video, see if you can do this one on your own, and then restart the video and make sure that you got it right. Hopefully you did that. To get the K value, you would take 10 times 20, which is 200. And so that means our equation is going to be y equals 200 over x. There's our equation. If x is 4, we want to figure out what y is. And so I'm going to take 200 divided by 4, which means y is going to be 50. So if we have something that varies directly, and one of the points is 10, 20, another point is going to be 450. That's what we're going to be doing on our homework assignment for tonight. Again, we'll go over these tomorrow in class, but good luck on that, and we will see you all tomorrow.